All right, since I have to make a key, I figure I'll go ahead and make it with a video. Okay, so the first question here was just testing your ability to recognize when we might be able to use substitution. A pretty straightforward question. Typically, I don't like being this obvious by doing something like telling you a technique, but here we are. This is what I did last semester. All of these have an ln running about. With an ln, we are generally thinking maybe integration by parts with that as a u. In fact, that is the technique to solve the two here that cannot be solved with u substitution. There are two different problems here where we can see that ln of x being an inside function and a function composition, which is what we need for u substitution. We have that here and here. Now, the first one is immediately out. We have two separate functions being multiplied together. That is screaming integration by parts. This third one, we don't have what we need to do u substitution, which is our du floating about. So if we set our u equal to the ln of x, we know our du is going to be 1 over x dx. And indeed, we have a 1 over x, that's here, dx in that particular second problem. So this is the one that can be solved using u substitution. And now we've already got most of it set up. We are at cosine of u, and the rest of it just became du. We didn't even need to manipulate that at all. And then we know how to take the antiderivative of cosine. That's just sine of u plus c, and then we can go ahead and sub back in our u in that problem. So the ln of x plus c. There we go. The first one we've done many times. The third one is actually a pretty interesting integration by parts, so I just sort of want to mention it before we close this video. If you're not curious, feel free to stop me. But if we wanted to do that last one using integration by parts, we'd actually put the entirety of that integrand as our u, because we can take the derivative of anything, and we're just going to hope that that derivative gets better. So let me turn on my locks. I learned how to do this last time. All right, I think I unlocked them. I think I made it worse. No, I think they're locked. I don't know. We'll see what happens. What? Hold on. No, I think I'm fine. I just lost my green, which I find upsetting. This is great. This is good content. This is what everyone wants to watch. Anyways, I'll just switch back to green. We'll be fine. All right, so u is equal to this whole thing, the ln of x squared. I can take the derivative of that using the chain rule. That means my du is 2 ln of x times the derivative of the inside function, which is our ln of x. The derivative of that is just 1 over x. We are stuck with our dv then just being the dx and our v being x. But hopefully you already see the magic that's going to happen here. When we use the integration by parts formula, we're going to have the ln of x, that whole quantity squared, times our x minus the integral of, and look, we have an 1 over x and an x. Those are going to cancel out. So we're just going to have the integral of ln of x dx. Now, of course, that does require another integration by parts if you don't have that formula or that antiderivative memorized. But one more, it's only one more, and then you'd be done. But you'd have x ln of x, and this is, oh, I lost the 2, plus the ln of x, I think. Don't quote me. Oh, I needed 2 also. dx plus c. So that may or may not have a small sign error in it because I'm lazily trying to remember the derivative of ln of x without just doing another integration by parts, mostly because this video was supposed to be about u sub and I got distracted. So that was question 1.